Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Baraa.T, and this is the third assignment of the operating system subject. In this video, I will explain my CPU scheduling project in a simple way. I will explain the code, then I will explain the output. We will start with the process class here. This class represents a single process. Each process has an ID, has an burst time, how much the CPU time it needs. Okay, we have the remaining time, how much time is left, the waiting time, how long it waits. So this class is used to store information about each process. So now we will talk about the round robin simulation here, round robin algorithm. The round robin algorithm, it is the main logic. All processes are stored in a queue, and the CPU takes one process at a time, or gives it a small time with the quantum here. Okay, it is finished. If it is finished, remove it. If it is not, put it back at the end of the line, of the end of the queue. So here, at the same time, all other processes increases their waiting time here. And we have a simple idea. Everyone takes turns. We will talk now about the starvation simulation class here. We create B1 with 2 milliseconds short time, B2 with 2 milliseconds short time, B3 with 20 milliseconds. It is a long time here. The problem here, all processes are treated the same way, so the long process keeps coming back many times here. This makes the other wait more than expected. So we have the starvation fix. We used aging technique to fix the starvation here. Um, the solution here, after running once, we sort processes. The one that waited the most goes first here. The one that waited the most goes first. And we have an important notice here. This doesn't reduce the waiting time. It just improve the fairness here. Now let's talk about the overload simulation here. We create 10 processes. Each process will need 5 milliseconds. The problem here, the quantum is 1 millisecond. So the CPU will keep switching too many switches. That means slow system. So we have to fix it with the overload fix class. This we increased the quantum from 1 to 3. So the result, fewer switches. That means better performance. Deadlock, we will talk about the deadlock right now. The deadlock simulation. We have resources, resource 1 and resource 2. Um, Resource 1, B1 takes resource 1 and B2 waits here. B2 takes resource 2, R2, and and R1 waits. So we have here both are waiting forever here, so the system stuck. We will fix it with this class deadlock fix. Both processes takes resources in the same order here. For example here, first R1, B1 takes R1, then R2, then it's finished. Now B2 takes R1, then R2, now it is finished. So we will now go to the main, and we will run it. The main class, we will run it and see the output here. Now we can see the output. So here, the starvation output, we have B1 waiting 2 milliseconds, B2 waiting 3 milliseconds, B3 waiting 4 milliseconds. B3 has the highest waiting time. It is because it is the longest process here. After fix with aging technique, aging here we have B1 waiting 2, B2 waiting 3, B3 waiting 4, B3 waiting 4, B2 waiting 3, B1 waiting 2 milliseconds. The value did not change here, but the order changed. So the process that waited the most, B3, is now the first one here. Okay, we will go to the overload output here. Waiting time here are very high. are very high as we can see. So too many because the reason why there is too many processes and small quantum that used we used 1 millisecond. Now we with the bigger quantum the numbers are less. The waiting time decrease here. So and the reason why because the fewer context switches here. Now we will talk about the deadlock output. Deadlock before fix here. B2 locked R1, R2, B2 locked R2, B1 locked R1. B2 is waiting for R1 and B1 is waiting for R2. So each process holds one resource and waits for the other. So the result here, the system is stuck. After fixing the deadlock here, B1 locked R1, B1 locked R2. Then B1 finished. Now we will go to the B2. B2 looked R1, B2 looked R2, B2 finished. So the processes here follow the same order, no waiting, no deadlock. So the final conclusion we can talk about the final conclusion here. The starvation solved using the aging technique here. The deadlock solved using the resource ordering. And the deadlock solved. The deadlock. I'm sorry. The starvation solved by using the quantum bigger quantum to increase the quantum. So, and the deadlock using the resource ordering. So these solutions improves the fairness, improves the speed, improves the system stability. Uh, and this is our assignment. And thank you for watching. Wassalamu alaikum wa rahmatullahi wa barakatuh.